This is Miss Guthrie, and I am going to walk you through the creating of your balsa bridge design. So in Onshape. So the first thing is when you log into Onshape, I want to just introduce you to a few things. First off, if you click on at any time the Onshape icon in the top left corner, it will bring you back to this dashboard page. And mine may look a little different than yours, but basically over here you can see things that you can access that's more organized. You can see things that have been recently opened and so forth. You may get notifications, especially if I put comments on your bridge, and it's a good idea to look over those notifications periodically and exit them. So we're going to, you're going to follow the teacher's instructions for getting started. In my classes, we typically have an assignment that you would be able to find in your class. For example, we have this bridge design project going on. So we're going to be creating a project. I'm going to create it from scratch. You may create yours within the assignment that you've been given. So I'm going to create a document. I'm going to call this sample video. So when you come in and you create a brand new document, it gives you a part studio that is empty, and it gives you an assembly that is also empty. And this is kind of where it starts you. There is a plus tab down here where you can add other things as well. We'll add a drawing later. Up here across the top are a lot of tools, and some of these we will use and some of them we won't in this project. But if you at any time you want to know what something does, you can hover over it, and if you stay there a little bit longer, it will tell you a description. So we're going to be using the sketch tool, the extrude, and that is the main two things we will be using that you see on the screen right now. Over here there is a history where you can actually see everything you've ever done. You can also add comments as well as read comments from me or anybody that you're collaborating with. And there's some other features over here as well. So I'm going to exit out of that, and we're going to begin to get started. So this is showing you that you have 3 different work planes that you can build on. And in CAD modeling, typically you build on a 2-dimensional shape on one of the work planes, and then you extrude it to give it that 3rd dimension. So that's how we're going to be doing our bridge, and a little different than Tinkercad where you started out with 3-dimensional shapes and drug them to the work plane. So I'm going to click sketch to begin getting started, and it will prompt right up here to select a sketch plane. So we are actually going to begin using the front view, and I can actually come over here and click it on the view cube as well. Be mindful you can actually click and drag and move that sketch thing there around, so if it's in your way. Depending on the size of your screen, you may not see every tool. Notice that our toolbar has changed when we're in the sketch menu. So we'll use quite a few of these. So the first thing we're going to do is we're going to be drawing the first balsa stick that will be the bottom of the first side truss. So in doing so, we have some options for drawing up here. I'm going to use the rectangle. There is a couple other types of rectangles you can use, but I'm just going to use the corner one. This is your point of origin right here, and we are currently working on the X and Z axis. Z gives us height. So this is like our left to right, and this is our up and down axis. You can see the X and Z over here. All right, we're going to start at the origin, and it doesn't really matter which direction you go, but be mindful to be consistent. So I'm just going to kind of go up and over, and I'm going to click. I'm not stressing over the dimensions because the next very important tool that you will use is the dimensioning tool. That is this arrow right up here. So with a rectangle with 90-degree angles, you can dimension a side like this. When we're doing diagonals and it's a parallelogram, you cannot do it that way, but I'm going to start there for now. I'll show you that when we get there. All of our balsa sticks are 1/8 inch by 1/8 inch. If you look at them on the end, they are 12 inches long, and 12 inches is the maximum length of your bridge. So the span that we are going to be covering is 9 inches. Right now, this drawing is 1.7 inches or a little less than that. And we can make this, I'm going to make it 11 inches. And I'm going to click front again and kind of recenter my drawing. Okay, so now we have drawn the first two-dimensional balsa stick. Notice that we are drawing it. It has height in this case because that goes up and down. It's got the length there. We will add the third dimension, the depth of it, when we extrude after we get done with our sketch. There is a lot of potential ways to go about drawing sketching our bridge. We can have a bridge that looks kind of like a tall triangle. Excuse me. We can have one that looks like a trapezoid that has more of a flat top and slanted sides. And I've seen we have a lot of trusses that are simply rectangles. In many of the truss designs that you may have already looked at, you will notice that no matter what, they all contain triangles because we know that is a very strong shape. But it does not have to be in the overall shape of a triangle, although it can be. I'm going to make mine in the shape of a trapezoid. I just kind of like the way they look, and I feel like I can make it pretty strong. So what I have just clicked on, I clicked on the line tool, and then this is a construction line toggle. It toggles back and forth between either being a construction geometry, which is part of the bridge itself, or a construction line, or regular building line. So what you'll see here is I can come in, and once I have those selected, Onshape is really smart, and it will know that I am trying to find the middle when I'm starting to kind of go back and forth around the middle. And you can see those little yellowish orange boxes that are forming. I'm going to click that and go straight up. The maximum height of my bridge is 4 inches from top to bottom. If you include a substructure, which is a smaller structure underneath the bridge, you may want to keep in mind to keep the top part a little shorter. So I think I will model it that way, and I'll keep this top part 3 inches. And I'm going to come back down here and click and drag down about 1 inch. And escape. And I'm just going to type that in so that it is more precise. And even though that looked like it was 3 inches, you can see that it's not quite, but we can make sure that it is. Notice that both of these lines connect to each other to make 4 inches total. it is not required that your bridge be 4 inches tall. So if you decide to have one that's a little shorter, that's fine. Or if you decide not to have a substructure, you could have one that's 3 inches tall, 4 inches tall, or whatever. All right, so we're going to stop there. This is just how tall I decided to make mine. Depending on how strict your constraints are and how your teacher's tolerances are, if you're going to be building like from this dot and going below there, so I will show you like a center point rectangle, which is what I would like to use here. Notice that this rectangle goes above that 3-inch mark. In my class, we are allowed to have an 1/8 of an inch tolerance, so that might not be a big deal necessarily, but that may be something that you might be sitting here looking at and saying, well, by the time I add the lateral bracing on the top that we'll do in a bit and anything else, I may want to make this a little bit shorter. So in doing so, we can actually just say, let's say we want to make this an 1/8 of an inch shorter. CAD is really cool because you don't have to necessarily do the math. You can put in the equation. So maybe I want to take off an 1/8 of an inch to allow another stick of balsa up at the top. So if I put in 3 inches and take away that 1/8 of an inch, hit enter, and it will automatically do the math for you. And you could do the same thing on the bottom. So 1 minus, you do have to put fractions in parentheses so that it keeps it together as a fraction. So that is a recommendation, especially if you're dealing with very strict constraints, that you keep those in mind as you're planning. Okay, so now I'm going to begin sketching, and I'm going to use this center line that I've made as a reference point to draw from. And like I was showing you, I'm going to start with a center point rectangle, and I am going to just kind of draw it out. And hopefully if you are designing this, you've sort of got a drawing that you are going by, and you're not just winging it. Since this is just an example and I'm modeling it for you, I am just showing you one way. This is not necessarily saying that it's going to be the best way. So there is a 1/8 inch. Remember, this doing it on that side of that rectangle works fine. If this is a diagonal, which we will have in a moment, you cannot do it there. You have to measure across, and I'll show you that in a second. All right, so if this is 11 inches, that means there's 5.5 inches on this side. And maybe I want to keep this, I'm trying to think of how big to make this. So if it was 11 on the bottom, let's make this 9 across the top. And I'm allowed to make this as long as 8. So I'm going to go with that full maximum width. And let's go with another rectangle. I'm going to use a corner one. And I'm going to show you there is another tool that we can use that's really handy, and it is the mirror tool. So for that, we are only going to stress on, I'm only going to work on building this left-hand side. We are going to reflect everything over that construction line that we put in, and that way we will end up with a perfectly symmetrical bridge. You can use the mirroring tool, which is this one right here, across all in shorter distances as well. And you can mirror across all kinds of lines, not just construction lines, but that is a very handy, one of my favorite tools. All right, so we have a 9 inch across the top and that's pretty easily divisible by 3. So I am thinking if the top has 3, I think I'll do that. 3 across the top. All right. So there is a tool here called split, and we can split an existing line into smaller parts. I'm going to show you what this is going to look like here and here. And I am going to measure this to be 3 inches. And from here to here to also be 3 inches. Why you not like it? So I think that it automatically just knew it was going to be 3 inches long. So that should be, when it's grayed like that, that means it is, the CAD program already recognizes that it's 3 inches, so it's really not necessary to have those in there. I'll delete them. All right. Each of these dots are 3 inches apart, so I'm going to be putting in some rectangles right there. To help with that, to help keep it symmetrical, I am going to use this handy dandy construction line to come in here. I've already got the other one. If you're using a tool, I should have said this before, if you're using any of the tools and you've done what you need to do and you're ready to, you're trying to move on, but it still keeps trying to do the tool, you can hit your escape button and it will, and I'm not going to worry about doing it on that side actually. I said that a second ago. So sometimes I have to remind myself. All right, we're going to draw a parallelogram in here. And now I could go all the way to there, but I'm going to be adding another line here. So I'm actually going to escape. I'm going to draw it one stick of balsa at a time. So for this one, I'm going to go and connect it like that before I start my next one. And then now don't worry about it being perfect. There's a couple tools to help with that. But I'm going to escape. We can look at it and tell these are not the same width. Watch carefully. These are diagonals, and I've mentioned it repeatedly how easy these were to dimension. When you're going across a diagonal, you need to do it across the middle. So click the first one, then click the next one, and it will switch because it knows you're doing a width, and then make it 1/8. If you get an error message, sometimes it will click into weird places on your whatever you're connecting it to, and you may have to do something, look carefully at what it's connected to. All right, so there is that. And I like the way that looks. So I'm going to use this as a mirror tool. Let's see what it looks like once we do that. Select a mirror line. So this is like your line of symmetry. Now select the entities, the parts that we want to mirror. This one, this one. Notice it did not quite go to there. This one, this one. So even though I can use that as a mirror line, because of how I've designed it, I'm actually going to undo that function. But sometimes this may work out really well for you. So instead, I will draw the next part on here. And I'm just going to connect it to this top line. I am drawing the stick of balsa. So be mindful that you have to draw both parallel lines for it to be a stick. And let's do it again. Then we'll go back and make sure that it is like we want it. All right, it wants to lock into that middle line, and that's perfectly fine with me. Alrighty, so now I've drawn in these two lines. Let's see if it will let us dimension across. Good, 1/8. I'm actually going to undo this. I want to show you something that may happen. Let's delete that line right there. One of these lines. Oh, I'm still on my dimension tool. That's why I was not doing it. Okay, so in the case of what I did, actually, let me delete the other one. So I drew in lines and it sort of kept them parallel, but sometimes you may draw it and this is kind of obviously not parallel, but sometimes it's not always so obvious. Let me draw that line back in there the way it was. All right. So if you go to dimension across two lines that are not parallel, you will see something that looks like this. If you see degrees, like that little circle up there by the 5/7, that means that you need to hit escape and go up here to your tools. You may need to pull down the menu if you don't see it. Find this tool that makes two lines parallel. There's a lot of other great tools in here as well. You can make lines horizontal, vertical, perpendicular. You can make coincident lines, or points where you can make things touch at one point. There's a whole lot of great things here, but parallel is useful. And you just click one, and you click what you want it to be parallel to, and it will make them parallel. Then you can come up here and dimension it. And I wanted to show that because when you're drawing in these lines, sometimes you don't even realize they're not parallel until you try to go and make them dimensioned. All right, so now I have created two triangles, and I know that they're not exactly the same size, but that's okay because we're going to have a symmetrical bridge. And now I'm going to mirror it across this line, and this time, try this again. The first thing you have to do is select the mirror line. Now select the entities. Only select the things you actually need. If you don't need construction lines now, you don't need them, don't worry about it. I've already added these, so I'll go ahead and add that down there. There we go. I'm going to hit escape because I'm done mirroring, and this is not too bad. I do want to add something down here in my substructure. Rectangles by themselves are not very strong. They deform with very little effort. So we're going to draw in some diagonals, kind of like what we did on top, but I'm going to just do this one nice and big. And let's see, if the force is pushing down in the middle, I think what I will do is start from the middle so that it kind of presses back, and kind of going to go there. I'm going to start from this corner and go back towards it. Again, I'm keeping it nice and simple. Here's another thing that might happen. I'm going to show you. Onshape does a really cool job of trying to click things into place for you. And so most of the time this is not an issue because it will literally click it into place. However, if you accidentally leave a gap there, one thing you will notice is it does not shade it in. Like, Now, it may be that that gets so close when you're drawing it in. Let's see if it will let me just extend it. Let's say you're super, super close, okay? If you're zoomed out, you may not even notice that that's not touching. So when you go to dimension it, it will let you dimension. But here later, when you go to extrude it, and I'll just hit this check for just a minute. If I go to extrude this shape, which is the next step, you have to select the pieces to extrude, and it will not let me select that stick. It'll let me select the others, but it will not let me to select that one. So if those kind of things happen, you've got to go back into the sketch, and this is where that coincident tool will really be helpful. So coincident means I want this point to be on this line, and see how it automatically adjusted that distance while keeping everything else true. So I just wanted to show that little feature to you, because sometimes you run into problems and you don't know how to fix them. So if you run into something like that, there's how you can fix it. Now I want to make this diagonal match on the other side. Do you remember which tool we used? I hope you're thinking the mirror line or the mirror tool. We're going to select this mirror line. It really would not matter if you selected it here or here. And then we're going to select the things we want to mirror. And on that note, we really are done with this sketch. And we're going to, does not look like a bridge. So we're going to go back and double click on the extrude that we had started. Notice that I did not come up here and click the tool. Once you've already got a sketch and you've already got extrude, you don't click sketch again, because that'll start a new one. You continue with the one you're working on. Now you will come in here and you'll select each of your sections. If you accidentally select something that you do not want to be a balsa stick, just click it again. You don't need to get out of it and get back in it or any of those things. It's kind of like an off and on switch. So when you click it, it turns it on and makes it a balsa stick. And the program does not know what is space and what is a solid until you tell it. So that's what we're doing. We're defining what's what. And as you do that, you notice all these things. What did I just do? Crud. Oops. Well, you can see what I got going on here. Let's go back into that extrusion. Hey, things happen, right? And if it happens, you don't freak out. You just go back to it. Let's see what happened. So the one thing I want, and this is actually a good angle to show it, the default depth is 1 inch. Our balsa sticks are only 1/8 inch wide. So we do want to change that to 1/8. You are also welcome, by the way, to use the decimals 0.125 if you prefer. But I find most students are happy with 1/8. Okay, so now I have a truss, and it is beautiful. I am very happy with it. I can look at it from different angles, and it looks like the truss that I want to build. Alrighty, now we need 2 of these trusses, and we want to add a top, and we want to add some roadway parts. So let's go to the assembly, which right now has nothing in it. We need to insert a truss. And if you accidentally click over here, it will start to move around and follow your mouse. But if you click back to this insert, it'll go right back to the origin. And that's one of the reasons we started it at the origin. Hit check. And so now we have this assembly with a truss. There are probably multiple ways to create a copy and move it. One way, though, that I'm going to show you is to use a pattern tool. So I just think this is very convenient. There is an assembly linear pattern. This is also very useful in the sketch menu. Later we'll use this for a different purpose, and it's very, very helpful to do things multiple times when you want things to be precise. So it tells us, when you click on that linear pattern, it tells us what is the instances that we want to basically make copies of, and that is that. Now the direction can be a little tricky. You will want to turn this a little bit so you can see, and you can select a certain side. So you want it to be any of these edges that go across from that little short 1/8 inch side. Think of that as being an arrow, and it's pointing in the direction that you want to extend. So I'm going to click that, and you can see that now I have a parallel copy of that bridge. It asks us how many of them we want. We do just want 2. However, if we wanted to have multiple copies of this bridge, more than just 2, you could. And how far apart do you want them to be spaced? Now, as we're looking at spacing them, we look at it from this right view, you are looking at it, the spacing goes from one edge to the same edge of the next instance, the next bridge side. So notice that if I want to measure all the way across this bridge, I still need to go 1 more 1/8. So that's just something to keep in mind. If you're trying to fit a 2-inch block, like what we're going to be doing down the middle, you need to make sure it's 2 inches from here to here. So when we're measuring from here to here, and we only do 2 inches, it's actually going to be a little short because 2 inches, again, like from here to here, if that's 2 inches, this is 1/8 inch shorter than that. So if you want it to be, I think that because humans are building these things and you have human error, it's always good just to have a little bit of cushion. In our case, our minimum is 2 inches, that inside dimension, up to a maximum outer dimensions from here to here being 4 inches. I kind of like the more narrow bridges, but I don't want it to be exactly 2. So I'm going to do 2.5, and that gives me a little bit of cushion. I could do 2.5 plus 1/8 if I wanted it to be a little, but we're just going to stick with 2.5. Oops, I put that in the wrong place. It said, how are we going to make 2.5 of those trusses? We want the 2.5 to be inches. And you can see all the different options there. We don't need any of those. All right, so now you have an assembly, and it has 2 trusses spaced perfectly apart at 2.5 inches. Remember the number that you chose, whether you chose 3 inches or some other amount. Just remember that amount that you chose. All right. Now, on that note, we want to build some things going across the top to hold our bridge nice and sturdy and straight. We also want to build a roadway. So we are going to create a new part studio. But instead of starting with a blank part studio like we started with before, we want to create it in context, which means we want to have this truss system that we're looking at to draw on top of. So this is the tool for that. You may need to look under a tool drop-down menu if you do not see it, but we're going to click Create Part Studio in Context. And it says to select the origin. find that, green check. And now down here we have a Part Studio that popped up. Before I get started, I'm going to go ahead and rename this Part Studio. If I right click on this tab, I can rename it, and I'm going to call it Truss. Truss. We have our main assembly, and I'm going to call Part Studio number 2. Let's call this our lateral bracing. You may also want to just call it the top. All right, so as you're in here, again, you've got your main assembly that's kind of a shadow. You can turn that shadow darker or lighter, and ignore this up here. You cannot move that one out of the way, unfortunately, but when you finish, you're going to want to insert and go to the assembly, so you'll just want that to stay there. All right, so we're going to do lateral bracing. Lateral bracing is going to be built on top of these 2 trusses all the way across. So we're going to use our sketch tool again. We always sketch when we're going to do something. And this time it's telling us to select a sketch plane, but instead of selecting top, front, or right, we're going to select where we want this to build. So at the top of these bridges, you'll notice as I hover over those faces that they highlight. And it does not matter if you click the bottom or the top, but pick one. And now it is creating this context, this assembly in context. I'm going to click the top view so I can see what I'm doing. I'll move that little sketch out of my way. We're just going to use some beams right now. I'm going to grab one. On the top bracing, you do not need a ton of sticks. It's just for stability. It's not going to actually hold a load that's going to be pushing down on it. It's just keeping the sides of your bridge from hopefully, twisting or getting closer together. It gives it stability. So we're going to make a seek. The distance across, if you did 2.5, like I did, is 2.5 plus that additional 1/8 to go all the way across. Whatever distance you did your 2 side trusses apart, put that in, and then you can do plus 1/8 for your balsa stick. If you know the fractions, again, 1/8 is 0.125. You could just make it 2.625, but since that is not necessarily what I would consider common knowledge, typing it in is just fine. And notice it did round. That's just a setting. Yours may or may not. It is doing it to the correct amount, even if it rounds. Alright, so I've drawn one stick. It is on the top of my bridge, where I want to place my first stick at the end. And now I want to draw several of those across, and there is a linear pattern. Also, just like we had one in the assembly, we have one in the sketch toolbox. So I'm going to click that. It does not prompt us, but we are going to select all of the 4 sides of the rectangle that we just made. And what these numbers mean and these arrows, this is showing us which direction we want our pattern to go in. This is showing by default they are 1 inch apart. Again, that's from same edge to same edge. And it automatically defaults to making 3 of them. I'm going to make this 5, I think. Yeah, that'll work. And instead of trying to determine how far I want these apart, I'm just going to drag it down till I see it where I want it. And you can see I want it to be at the very end down here. So that's pretty darn close to where I want to be. And I'm going to zoom out. Oops. Obviously I went too far. I think I set it and changed it to 5 at the same time. All right. Notice that that's hanging off the top. I don't want that. I'd rather it be slightly shorter than be hanging off. So that will do. And it automatically placed them in equal distance apart from each other because it's a linear pattern. If I'm content and happy, I can green check. One thing I do recommend is that you have at least a couple of diagonals on your lateral bracing. You do not need a ton, but just a little bit. Remember, triangles are strong, but rectangles are not. And I just did something that is not what you want to do. I accidentally clicked the sketch button again. And I'm going to delete this sketch because I do not want this. Actually, I just read X because I didn't actually do anything. I need to double click the sketch 1 because we want to do this in the same sketch. That is a common mistake, and it's a pretty big mistake actually whenever you get ready to do things later. We want all of these sticks to go across from top to top because you got to have something to glue to. You want gravity to help hold this together as it's drying. So we're going to glue it. I'm not going to stress about things being perfectly distanced. I just want to get it across from here to here and kind of sketch out my parallelogram. Onshape. You might have to use, let's see if it will let us dimension it. We might have to use the parallel tool. Yep. You can always tell when that happens because it is not what we want. You see the degrees. But I find that this is one place you see that parallel tool frequently having to be used. Again, if you're dimensioning a diagonal, do not come down here and dimension it at 1/8. If you do, it's going to be too skinny. And you can probably eyeball that and tell that this is skinnier than that one. If I try to do this across at 1/8, I get all these errors. And that is because you cannot be 1/8 here and 1/8 there. So you've got to get rid of that other one if you accidentally do that. All right. So I'm going to put one there, and I'm going to have one that matches on this other side. And I'm just going to draw it in. I could put in a mirror tool, but it's just as easy since we're just talking about a couple lines. You do want to make sure that you're closing this entire parallelogram. The sides of that bridge is not a part of it. So you just got to make sure that you draw all 4 sides of it. I'm going to go ahead and use my parallel tool and dimension 1/8. All right, I'm pretty content and happy with how this looks. And I'm going to click the green check. And I'm going to extrude it. So extruding it involves making sure that you do check all the little pieces. So on the side that you made your sketch plane, it will force you to check all of the parts. I'm not really sure why that is or how to prevent that, but it is something to be mindful of. Otherwise, it will not show your balsa is going all the way across the bridge. All right, if you are satisfied with how it looks, green check, insert and go to the assembly. And it's going to tell us, well, what is it that you want to put in the assembly? We want all of this. So you can come back through and just like we just selected it to extrude it, you can do it that way. Or you can click over here in the parts list one at a time. Or if you click the first one, hold the shift key on your keyboard and click the last one. You can select everything in the middle. that is a shortcut that works in a lot of different places on the computer. If you're trying to delete a bunch of emails, you can do that as well. Green check. Notice it has brought us back to our assembly. And now our assembly includes the top. Do you see the mistake I made? I bet you do. It is not extruded to the right amount. So let's go back to the extrude. The default is 1 inch. 1/8 is what we actually want. So I'm going to green check. And go back to my assembly, and it automatically fixes it in the assembly and any other places that I might have, it might have impacted. So that's very good to, one of the benefits of CAD is if you make a change, it knows to update it in all the places. All right, now we need a roadway. So the requirements of our bridge is that we are going to be, here's our roadway is going to go in above the substructure and at the bottom of the superstructure right down here. We're going to be placing a test block in this area that's going to be pulling down on the bridge itself. So we need to have enough support to help distribute those forces. So we're going to need to put in some members. Depending on if this is a different year or a different teacher, you may have a sheet of balsa that you use, or there's a lot of different ways that teachers do this. So I like to just use the 1/8 inch balsa sticks. So we are going to create another part studio. Technically, you could do it in the same one, but sometimes that can get complicated. Find your origin, green check, and sketch. Select a sketch plane. This time, we are putting our balsa sticks on top of this part of the bridge. So that face that you see right there, which is at the same level as all of these faces, the same plane, all of these faces right here. So you can actually select any of them. I'm going to select this one. It does not matter which one you pick, but you can tell now I have created this new context for this part studio. And let's look at it from the top again. So I've got this here. And one thing I do want to mention. When you are building and you've got acute angles, so I've got all these acute angles here. The balsa sticks, when you look at them from the side, they are these little squares like this. So, you know, you need to be able to stand up. So you don't necessarily want it to be all the way in this corner. Otherwise, there's nowhere for that straight 90-degree from your stick to be. So depending on how sharp these angles are, how small the actual measurements are, you can be, if it's a right angle, you could be right up next to that corner. But if it's an acute angle, you're going to have to come out here some. What I encourage is that you think about having plenty of road bracing, especially at the ends and in the middle where your load is going to be held. So, but we're going to use the linear pattern again, just to make this even easier. So let's look at it from the top view. I'm going to draw a rectangle, but I'm not going to go all the way to the end because of that acute angle. I'm going to come over a little bit. All right. I'm going to hit escape. And I'm going to dimension this balsa stick before I do anything else. It is 1/8 inch, always 1/8. And if this happens, don't stress it. It's just because when you made it smaller, it reduces it like in a scale all the way around, so it reduced the other side too. So if you remember, you place these two, however far you placed them apart. I was 2.5, and I need to add the 1/8, so it will go all the way across, and I do want to put that in parentheses. And now you will see it goes all the way from one end across the other. Do double check that that is how you draw it in there. By the way, that view cube can move. And if that does not look like that, you may want to redo it. If you like it, come over here and do your linear pattern, and it's not going to prompt you. Many of the tools in here will prompt you with what to do. This one does not. Notice you don't see anything happening, and that's because it always defaults to building it towards the right, but we can drag it in that direction also. And I did not mean to, I want to keep that, make sure that it's going straight and not a diagonal. Hopefully it will. There are currently 3 of them, and just me playing around with it, it's 2 point whatever apart. In this case, I want to think more about how far apart they are. Remember, I want them to be relatively close together. We are measuring from this side to the same side on the next balsa stick. And in our parameters, our constraints, we want this to be from inside edge to inside edge, at least 1/2 inch. That's the guidelines that I've given to my students. So that means that if I do it 1/2 inch from here to here, this from the inside is going to be 1/8 inch too short. So I can do a 1/2 plus 1/8, or I can just basically say something that's a little close to that. So I'm going to just do 0.7, but you can do something like 0.5 plus 1/8. That would make it exactly the distance, but I'm okay with it being kind of close. So that would end up being 0.625. This is a little bit bigger than that. And now, as far as how many I want enough to go across the bridge. So let's try 18. Pretty sure that's going to be too many, but what you will notice, these dotted ones, that just means that, and the pattern will continue. Whatever is in between the 2 dotted ones is what you're seeing. It's the same pattern, so everything's good except for these are too long. So let's take out, oops. All right, let's make this, try making it 16. And I am not using a mouse right now. Now 16 looks close. I'm actually going to do this. I'm going to reduce this to 0.65. And that brought it in some. You can play around with both until you get it like what you want. I think that looks pretty good. Looks fairly symmetrical. All right, so very quick way to draw all the sticks in. And I'm going to look at it from the front now. The reason this is important that you look at it from the front view is you may have some things in conflict. So what I notice is these first 3 look great. They have plenty of room to extrude up here, to go up 1/8 inch. This one, if I go all the way across, I am hitting at that joint. That one will not work. The next 4 are great. That one might be a little too close, even though it might work or it might not. It'll be very close. We might just leave that one alone and see what happens. This one is a problem. So the 4th one in on both sides is problematic. So look at it from either the top or bottom view, and you can just select and delete anything that you had that was in conflict. If there was one that you did and you're like, man, it was really close, you can just come back in here and like you could draw another one in if you wanted to. I'm just saying you could. Because we have so many, we put in plenty. Oops, thought I was selecting. Because we put in all that we did, we don't need to necessarily stress about adding in anymore. It's okay to delete a couple. All right, I am very happy with how this looks. I'm gonna green check. And now I will extrude. Now this is a little tricky because you have to make sure that you're doing just the roadway and not the lateral. It's really easy to click the wrong pieces. I'm gonna do 1/8. Remember, I forgot to do that last time. So look at it from the angle that best suits you. You might have to turn it a little bit, but you want to make sure that you're getting just the ones that are going across the road and not the ones up here. It will let you select them, but that is not what you want. And just like we had before, wherever your plane, the sketch plane that you selected, it will not select those little pieces. So you got to come in here and manually select those little squares as well. And again, if you're having a hard time, if it's selecting like the whole piece, try tilting it and looking at it from a different perspective. All right, let's look at it from the front view. I want to look closely at this one. Yeah. So that one ended up turning out okay. You can tell that I can actually place it there. It'll be up right into that corner pretty well. If it overlapped here, then that would not have been good, but this will be just fine. All right, I'm very happy. I'm going to hit the green check. I'm going to insert and go to the assembly. Select what we want to be inserted. You can pull this up so you can see it. Remember to select all the parts that you just did. And green check. Here is my assembly. And here's my completed bridge. All right. Very nice. All right, so we're going to now, let's see, I'm going to rename Part Studio 1 as the roadway. And now we want to make a drawing. So in the rubric, you're asked to have a scaled drawing that shows your bridge that meets all of the requirements. So if you're building this bridge, you're going to create a drawing, but you're going to create a drawing that is a 1-to-1 scale. So you may come on here, and there's a couple different ways to do it. But you can come on here and go to your sketch. You can create a drawing of each one. And I'm just going to show you this even if you're not building it, because I think it's good for you to see this. If you did do something that is like a triangular shaped bridge and your lateral bracing is kind of diagonal, then you can't do a top view drawing. You'd have to do one from the sketch, like what I just did. B paper is 11 by 17, which is really big. It's like 2 normal sheets of paper in one. And A size paper is a normal size sheet of paper, the 8.5 by 11. ANSI and ISO are 2 different like standardization sort of, kind of like MLA and APA. Different formatting for different organizations, depending on what people's preferences are. Different standardized ways of doing something. We're going to use ANSI, and since all of our stuff was in inches, I'm going to do B and no view. If you were going to be doing this for drawing purposes, I would say you don't necessarily need a border, you don't even need a title block. You just need it to be on B size paper, and using the custom template is probably the best way of doing that. And you would want to make your actual drawing to be 1-to-1. The advantage of using the sketch is you will see all of these lovely angles that get cut, and you can physically lay your balsa sticks on top of this and mark it with a fine pen and use that as cut lines. So if you drew it and you made a lot of crossovers and the lines cross over everywhere, those are things you can clean up using your trim tool. I'm not in that function right now, like I'm not in the sketch. But the trim tool looks like scissors, and when you click on things, you can easily remove them. If you don't like the construction lines, the trim tool is also good for removing those as well. So, yeah. On that note, the other thing is, so you do the same thing for all the parts that you actually have to build. I am going to delete this sketch for now, and I want to show you how to make an assembly drawing. So we're going to create a drawing down here. I'm going to use B size paper, and this time I'm going to use an existing template. If you do not see all of those, you can say show the templates and it will show you all of them. But we want the B inch, that one right there. So, okay. And you can see we have a border. This is really good if you want to reference something on the paper. You also have, this is called a title block down here, and if you zoom in, you'll be able to see that your name is automatically put in and the date. Other things get automatically put in as well. So we're going to start off, what do we want this to be including? And in this case, we want it to include the whole assembly. So right now we're under Part Studios. We want to go to Assemblies. And because the bridges are fairly large, we're going to do this as a 1-to-2 scale. This is just for documentation purposes after we have completed all of the other buildings. So notice as you place one, when you go below it, when you come out here to the side, you get other views. In this case, this is called the parent view, and anything that you come off of it with is called a child view. So because I'm coming off the bottom, this is my bottom view. And if I come off to the side, this is going to be like my right-hand side. So I want my students to add all the main views. So we're going to look at it from a front view, the bottom view, the top view, and then that side view. And then we're going to also add an isometric. I'm going to do it at 1-to-2, so it will all fit on one page to make printing easier. And we're going to add, I've already done the side and the bottom, so I'm going to put the top on here. And I'm going to insert the isometric. So what you'll notice is you can kind of move some things around. If you move the parent/child, either of them, it will kind of do things together. So they're sort of attached. So think of it like this. If you were to come off of this one and go straight over to there, the top and the bottom line up. And these ends are going to line up perfectly. Whereas this one, because I inserted it separately, I have a little bit more freedom with it. I'm just going to kind of manually line it up. And same thing with the isometric view. Lets you sort of see what it looks like as a 3D. All right. The next thing that is really important is that we add in the required dimensions. And there's a lot of ways to do this, or there's a lot of dimensions you can add in here. You can literally add in the distance between anything if you select it, but we're going to add in the overall height, and I could use this one. I can use either of these that show the top to the bottom. Cannot use these two because they show left to right. I think I will use the right view. And it does not matter so much where I pick on that top, as long as I make sure I'm at the top or the bottom. Okay. I did not do that quite like I wanted, so I'm going to do that again. Top to bottom. There we go. So how tall is my bridge? My bridge is exactly 4 inches tall. For me, that's great. If you are under tight constraints and 4 is your maximum, this is fine. If you have some tolerance, then that works too. This little tool right here lets you do some properties. I'm not doing anything with that right now, but there's some, this is where you can set the decimal places, you can set all kinds of little things there. All right. Another dimension that is very important is the inside to the inside. So I'm going to, because I want to make sure my 2-inch block fits, and it should. Even if I have a little human error and my sides don't stand up at perfectly straight after I get done building it, which hopefully they will, but you know, if it is your first time building a bridge, sometimes it's hard to be perfect because we're not a machine. So we want to make sure it's at least 2 inches, but if it's a little bit more, that's good. Very well. We also want to make sure that the outside dimensions are less than 4. Now, even though I know that they are, because that's one of our requirements, I'm adding that on there. This proves that it is under 4 inches. It sort of defines it. Now, I'm going to look over here at this one. What is really important about this one is I can see my substructure really clearly. It's the only view that I can really tell how wide my substructure is. And so the maximum width of that substructure is 8 inches. I want to make sure I grab the furthest points so I can prove that that is 8 inches. And since I'm doing the width, I'll go ahead and do the width on this one as well, from outside edge to outside edge. And it's 11 inches. So those two are required. If you want to show how wide your bridge kind of is, and actually I'm going to escape from that. I do not want to do it on the top part. I want to do it with the actual trusses. They're actually, the top part I got close to the end down here, but I didn't stress about it being right on the very edge. So on this one, I do want to make sure I'm on the edge, because I made that to be 9 inches. So that helps define some things there. So if somebody wanted to actually build this bridge again, they could see the measurements. We could add in other dimensions as well that are kind of optional, such as, this dimension. We could add in this dimension, those kind of things, so that but these two they were not a requirement, so they're not necessarily required to be there. I'm just showing them to you. One thing that you may want to include, and we'll look at the bottom and the top for this, is we do want to make sure that between the roadway pieces, so this like Z line and then another Z over here, that's my lateral bracing. All those other ones are part of my roadway, and specifically between here and here, this is where my testing apparatus has to be able to pass through. So I want to make sure that between here and there is at least half of an inch, that it's more than 0.5, and it is. So that's perfect. Really and truthfully, that is all the required dimensioning that is necessary. Because it's already defined up here as being 11 inches, you do not need to draw it in again. You don't need to do this. It's already been done. But if you felt like this was too cluttered, you could do it on different drawings, just to reduce the clutter. One thing we'll notice that it says down here, it says, unless otherwise specified, dimensions are in inches. If this was not stated, we would want to make sure that it said on here that the dimensions are in inches. Units are important. So this is just showing you important things there. Oh, one more thing that you need to do. I was just sitting here thinking there's something else. If you right click on any of these, actually right click on all of them and select all of your views, and then right click and go to view properties. Select to view the label and select to view the scale label as well. And then hit the green check. That is important. You may find that, like, if your dimensions are not able to be read, you may need to reposition some things. So like once I added that on there, this is a little messy now. So I'm just going to reposition it. And again, if I've already added 11 down here, so I'm gonna just delete this one. And that way it's not so cluttered. Yep, this one also. Very well. And now we can tell which side, what view we're actually looking at. And you'll notice they've added in, the scale has been added in as, since we did it all in 1 to 2. The size B paper lets whoever gets this digital file, they know what size to print to. And so your title, you've got some room here to add in. They've given you plenty of room. Put in your name. So I'm going to put in my name. Check. I may want to move that. Okay. Now, my name is not really required there since it is over here, but it's hard to see that sometimes. That's pretty small, and it helps me as a teacher to be able to see your name, or at least your last name. It just helps. It may be also useful to put your class that you're in, if you're in which period you're in the day. But really, this is all you need. So, on that note, if you need to submit this, there's a few things you can do, but you can go up here to export. This will export your PDF so that you can turn it in, or you can send it to whoever you would like to have print this or review it. I always recommend naming it something that makes it easy for you to identify, like your name, assembly, drawing, export, something like that. And you'll notice it says it's being prepared, and it asks you to save it. You want to look at where it is that you want to save things. So if you have a special folder for this class, you can save it there. You can put it on your desktop, so anywhere where you can find it. And then it always goes to your downloads as well. On that note, that is the end, and I hope this is helpful.